Hello, this is Mr. White, and this video is for solving equations with a graphing calculator by finding intersections, part 1. So here's an equation, x squared equals 2x plus 7. And if you've already seen the previous videos, or you've already learned how to use Calc Intersect to solve equations, you probably recognize that you could very well move everything to one side if you wanted to. You could choose to move everything to one side like this. And now you've got 0 on one side of the equation, and you could use Calc 0 to solve that equation if you choose. And the truth is that if a student wanted to stick exclusively to Calc 0 and never use this Calc Intersect, this intersection method that I'm about to show you, you could get away with that. So if you're wondering, why should I bother to learn how to use Calc Intersect? I'm going to give you that unsatisfactory answer of just saying wait and see and kind of discover for yourself. I think as you try both tools out, you'll develop your own answer as to why you might want to use one tool in one situation and another tool in a different situation. So let's not go down this road. Let me erase that. And let's go ahead and explore Calc Intersect. So I'll move that off to the side, bring up the calculator here. And here's the idea. Actually, before we touch the calculator, let me just go over the concept here. We are going to basically imagine the function y equals x squared. We're gonna consider that to be one function. And then we're going to consider this y equals 2x plus 7 to be another function, yielding another graph. And just to keep these two straight, let's call this one y1, and let's call this one y2, just so there's no confusion which equation or function I am referring to. Okay, so I'll move this aside. Now we'll grab the calculator, and go ahead and hit your y equals button. Hey, and look at that. There's a y1 and a y2 waiting for us to enter something in. So let's go ahead and say y1 equals x squared. And we'll scroll down here, we'll arrow down and say y2 equals that 2x plus 7. And the idea here is that when I graph these two functions, they are going to intersect. And where the y1 graph intersects the y2 graph, those points are going to represent our solutions to this equation. Okay, so I'll remind you that presumably you've been working on some other problems prior to this, and your window settings may be all screwed up, to put it in technical terms. So remember my recommendation. Start each new problem by, just as a default, go to Zoom, and then number 6, Zoom Standard. That is certainly not promising that that's going to be our best zoom setting for any given problem, but it's just a good place to get used to starting. And we can see here that, that we see a single intersection point on the screen, right where my cursor is, but you could probably anticipate, knowing what you know about parabolas and lines and their general shapes, you can anticipate that there is a second intersection point off the screen. So there are some suggestions I have for how to figure out what to make your window settings, but honestly at this point, for just starting out, let's just make an educated guess. That looks like it's going to intersect just a little bit off the screen, not terribly much. So right now with Zoom Standard, our Y max setting is 10. We're looking at a Y value of 10. I think a reasonable guess, why don't we just move that up to 15 or 20. So again, change your Y max value to 20. As always with these videos, I do ask that you follow along on your calculator. Don't fool yourself into thinking that it's making sense just because you're following what I'm doing. Follow along, please. Hit graph, and now we will be able to see that more of the graph has been squeezed onto the screen. We are now going from -10 to +20 on the y-axis, and we see our two intersection points. Okay, now we're going to go to Calc Intersect, and watch how efficiently I do this. I see a lot of students wasting a lot of time doing unnecessary keystrokes here. So again, really try to follow how efficient I'm being and how few keystrokes I'm going to use. I'll go to second Calc right above the trace button. And this time I want to go to Intersect, number 5. So again, instead of using the arrow keys, it's quicker to just hit number 5 on your keypad. And notice the prompt. It's asking for what is the first curve that I want to intersect. And up in the corner, in the upper left-hand corner of the screen, it says y equals x squared. And yes, indeed, that is the first curve I want to intersect. Here's where students waste time pressing the arrow buttons. Don't bother. As long as I've got the right curve selected, just hit enter right away. Now, look at what's in the upper left corner, y equals 2x plus 7. Is that the second curve I want to intersect? Yes, it is. Don't waste time using the arrow buttons. Just hit enter. Say, yes, this is the second curve. If you're wondering why these prompts occur, it makes a little more sense if I had 3, 4, 5 functions entered into the y equals screen. Given that I only have 2 entered there, these are the only choices, but the calculator still just prompts me for them anyway. But don't waste time with the arrow keys. Just hit enter, enter. And now when it says guess, here's where you want to stop. I told you when using Calc 0 that when you get to the guess point, just hit enter, but not the case here with Calc Intersect. Let's make an educated guess as to what our two solutions are. This first solution on the left-hand side, if I were to try to read off the axes here, I'd guess that's maybe at about -2 or so, just reading off the tick marks. I'd say that the other intersection over here on the right-hand side, that's probably at about, what, 3 or 4 or so? So just make your educated guess. And let's go ahead and guess for the first intersection point here, -2. Don't worry about being too precise. As long as we're in the ballpark, I'll hit enter. And there it is. There's my intersection point. So let me, looks like it's going to be stubborn. There it is. Okay, there's our first intersection point, and there is our first solution, x equals -1.828. Let's go back to the calculator, and let's do this again. And again, notice the efficiency. I'll do it a little more quickly this time. Second, Calc 5 for intersect. Enter, enter. Don't waste time with the arrows. I hope I made that point clear. But now pause when it says guess. And remember what we said our second guess is going to be? Look somewhere around 3 or 4. Don't obsess over it. Just put 4, let's say. Hit enter. And there is our second intersection point. So here is our second solution. Y equals 3.828. And there you have it. That is how we use Calc Intersect. If you're wondering what's the significance of the y values, if I were to take, let's say, this first x value, -1.828427, and plug it into the left-hand side of the equation and basically squaring it, I would get 3.343, this y value. If I were to take this x value, this solution of -1.828, and plug it into the right side, guess what I would get? The same y value. That's the significance of y. We would end up with the equation. If we plugged in this x value, we would end up with 3.343 equals 3.343, an obviously true statement. So that is how we use Calc Intersect. I'll point out once again, like I did in previous videos, that since this is an equation that can be solved algebraically, compare these two graphical solutions to the algebraic solution. And again, that's not the focus of this video, so I'm going to gloss over this, although again, the diligent student should be able to look over this and go, yeah, I know how to do that. But again, notice that it's the same solutions, whether you do it algebraically or graphically. So one method should complement the other, should be able to check the other. Now your turn to try it out. Okay, x squared minus 5 equals 6x minus 1. This is where you pause the video because in just a moment I'm going to reveal the solutions. All right, hopefully by now you've tried it out on your own, and let's see if your answers match mine. 6.606 and -0.606. A lot of sixes. Don't worry, that's not some kind of satanic omen there. That's just our solutions to this equation.